Hey, welcome back. So I may or may not just post the launch video before this. Yeah, we'll see. It's just pretty much the exact same as that previous launch, really, to be honest. It was just the Thor Able getting us into a lower orbit. I cut off a little earlier than I did the last time, and now it's all about aiming at the moon. And really, most of the last video is just me complaining about how hard it is to spend all the delta V. And as you can see, you could count somewhat. We really only have 30 live in-game minutes to until we actually get towards this maneuver node. But I've got a nice crash encounter here where we'll actually run into the moon, which would be nice. We're still 30 meters per second short delta V, and I'll show you why, or explain why. So everything untouched. So I've got tiny numbers. I'm just shifting this by 1 second, moving each of these by 0.1 meters per second. Now if I go, there, nothing. And I go back, okay, it's there. But sometimes there, okay, well, screw you too. One way, that way. See, I'm exactly where I was when I started the video. Exactly the same numbers, no encounter. It says, no, you're going to totally miss, which is horseshit. So yeah, you can see how much I love these. So that's really why I love to finish these things off with RCS or something, like doing a solid shot, or at least in reality it might work. Obviously use different systems to do the planning. There might be no more additional difficulty, but the pre-planning maneuver nodes here are just, and in KSP are just sketchy and crappy a lot of the time. Sometimes here I just had to click 30 times in faith that hoping I get something better, and it never ends up showing something, even though I know that I'm still in an encounter, right? Just because I've decreased how much I'm burning towards the moon by a fraction of a meters per second doesn't mean I'm all of a sudden not going to be anywhere near the moon, right? And so I just can't blindly optimize this. So I'm just going to stick with what it is. Really, I think I've got the ratios not too bad anyway, so I'm just going to hope that it goes. But really, that's why I like to do something even if, let's say, so I know to hit the moon it's going to take me this. So, I might actually build a package where, okay, so I have a solid, and the solid is going to fire me, 3,100, something like that. And then just finish off the last, 20 to, 1 meters per second through 50 meters per second with RCS. I'd just much rather design a craft like that. Let me see, do I have the roll controls on? Yeah, I do. Okay, now do I have them off? Oh, really? Does this craft not have that set up? No, good, it does. So see, now I'm hitting Q and E, as you can see from roll, and it's not firing those thrusters, so that's good. Basically need those to be off in order for me to be able to do this. So here's where persistent rotation really shines. So I just kind of oomphed myself just a little bit, just a nudge in the right direction, and now I can time warp, and it's gradually going to swing around to where I want to be, which is really efficient for saving you RCS in maneuvers like that. Okay, so I just need to kind of push myself a little differently down towards where the blue arrow is pointing. Okay, swinging by it somehow. Very well. Oh, there we go. Looks like it's near where the whatever that one is. I don't know if that's the radial or the normal vector, but looks like it's near there. So pointing straight down at the Earth. Okay. Yeah, I really don't like using solid stages like that for something precision like this. If I was just sending, let's say I'm just sending a probe to the vicinity of Mars, and I just want to get Mars orbit. Okay, so I just calculate roughly how much delta V I'd need, and I can package that in a solid, and that might either be more cost effective or have a better ISP than if I used RCS, or a hypergolic fuel in order to do that, in order to slow down into the influence of the moon. Also, of course, it's when you have tweakable procedural solids, if I could have set up so that this solid gave me exactly 3150 or so, and I'd probably be a little better. But here I kind of had to work with what I have, and I kind of left these stages not fully full either. All right, so 24 in-game minutes to that window. Yeah, there's some big contracts coming up, though. There's the re-entry vehicle. So once I have survivability, I can basically build a small probe. interesting. I kind of like if so. The requirements of that mission is to design a re-entry vehicle that reaches like quote unquote orbital velocity, which I think is actually coded as 6,500 meters per second. So relatively, close, not actually in orbit at all, but close to orbital velocity, close enough, and then close enough that it's pretty much the exact same challenge is what I mean, of returning something from orbit. And so you can lob like a bio package, for instance, a bio science out into space, and then recover it. So it needs a heat shield, it needs the ability to make sure it's positioned the right way. And I've designed those a few times with procedural parts and things, so I think I'll be okay for that. So here, I hit caps lock to reduce the thrust here, and I'm going to try to trust it here to point me in that direction. It's probably going to waste a good bit of my RCS, but I want to be super precisely pointed at my target there. And then once it's no longer really spending any fuel, okay, I'm going to, there we go, basically freeze myself on that point now. I want to very precisely fire myself in that direction. Yeah, that's going to be a really interesting contract. In fact, that's what Thor Able was largely flown for, was testing of re-entry vehicles, not for sending science into space, or not even for like sending early spy satellites. They couldn't send the pictures back down. They couldn't, beam them back down, or they chose not to anyway. And in part they couldn't because the transmission technology wasn't nearly as good at the time. That estimated burn time is way off, but we're going to start burning maybe 4 seconds before I hit the node. They actually had to return a bucket of film from space. So they would, send up a satellite. They would take pictures of the enemy from way high up, so they could see where missile facilities were, where construction was, true movements, etc., etc. Take whatever pictures they could with their remote satellite. And then they'd actually have to have a separate, part of the spacecraft that could pop off, slow itself back down so it caught in the atmosphere. It's amazing. You should look up the Corona program, and they're the keyhole satellites. It's extremely interesting history, and it's an interesting challenge to kind of do the simplified version of it in RP-0. Okay, so we're approaching the node burn time. So let's just hope that this maneuver, even though it's not it's going to have a slightly higher magnitude, my burn, than my planned maneuver. Hopefully I'm within 5,000 kilometers of the moon, because honestly I don't think I'm going to do any better than I did here with another launch, just because the thing I'm really fighting is the way that KSP calculates its maneuver nodes. Okay, so I'm there. Oh, of course, and the element I forgot was to spin up the craft. Nice. Oh well. Okay, so let me see if I add an orbit to this. Oh, come on, add an orbit, go back, add an orbit. Okay, so if I do this 90 minutes from now, what kind of adjustments will I make? It turns out if I do this 90 minutes from now, I'm not going to have any trouble. So all right then. So I'm just going to warp around another orbit. Let's wait. So all right, we'll get to see Earth. Yeah, and I really do need to spin this up. So that's what those other nitrogen thrusters are on there for. So we're heading to the moon pretty fast. If you were just doing like a light lob of let's say like an Apollo craft, you probably wouldn't be able to get away with that. Just to wait one more orbit, you'd have to make a bit more of an adjustment. But because we're kind of heading at the moon faster than the minimum speed that you can get away with, come on, it's going to be we're going to get away with this. Because the moon will have moved a bit in 1 hour, right? 90 minutes is a not completely insubstantial fraction of a month, I guess, is one way to think of it. So mostly went over oceans that time. I like to try to figure out what path we're traveling on just by looking. Obviously the clouds don't tell you anything, but when you see a chain of islands or something, it's often when I'm actually doing real work, I will have on one of my screens, I will have the footage from the ISS, and you can see land masses and all kinds of things from that. And this is somewhat similar to that, where you can actually make out a bit of land. Okay, so we're approaching that. You can kind of tell, I can tell what California looks like now. When the ISS is approaching California, or obviously certain parts of Europe, Mediterranean. There's lots of land I definitely still can't identify, but it's still fun to guess. Okay, so we're approaching this time here. Yeah, sending up spy satellites and returning the hardware is, I'd kind of wish it was like the second contract of re-entry vehicles, because right now that's pretty much what you'd want to do with your first re-entry vehicle contract, or if you're trying to farm it a little bit, like you might just pop a biosatellite up into space. So I need to not blow by it this time. So hit 5 to turn those back on. Oh, right, let's crank up the RCS power. Yeah, so I need to spin up my avionics module as well, so I have control. But right now, you have to be able to test a reentry vehicle, you have to get it up to 6,500 meters per second. Whereas in practice, like 2 or 3 years before this point, before 1959, which is kind of roughly where I am in the American timeline, they were testing reentry vehicles because even for medium range, intermediate range ballistic missiles, you need to start designing something that can arc back down, because if you're shooting something 500 kilometers or more than that for an intermediate range ballistic missile, it comes down really fast. So you need to design a special vehicle where the nuclear weapon that you're sending down in that will be assured to survive the re-entry of the atmosphere over the target that you plan to bomb. So they're doing lots and lots of testing of that before this. So like just like a number of the other contracts I've mentioned, like geostationary and geosynchronous and Millennia orbit, there should be kind of a step up of those contracts, I think, or at least it may be handy for newer players to kind of guide them to some of these more difficult contracts, to have like a bit easier versions of them that lead up to it. So similarly, the re-entry vehicle contract, I feel like there should be one where it simply pop something out into space and then have it survive re-entry. Because really at this point, like, I've not recovered something, right? Everything, like, the best I've done is putting something in space and making it stay there, right? Even though I've accomplished quite a bit with this, in America had accomplished quite a bit at this point, like really they had not recovered anything from space yet until they were starting to recover film from the Corona program. Okay, so we're pointed pretty close to that. Part of the issue is that these RCS thrusters aren't exactly around the center of mass of this vehicle, but that's okay. It will get a tiny bit of wobble, but maybe that wobble will kind of help in my favor, because it will make it so that we're not, some of the energy gets wasted in the precession. But yeah, wish me luck. It's going to be 2 stages of solids. Oh, 5 or so seconds till we light it up. All right, and there we go. Time to go. So we dump that and fire the first set of solids. I don't have control anymore, so I can't even turn off the RCS. And let's see what this looks like from the perspective of the moon. So here comes up the orbit, and no, I actually ended up doing worse than I did on that previous mission, unfortunately. And it's kind of flickering like this. So see, it recalculates every, some fraction of a second, whereas with the maneuver planner, it only recalculates each time you click. So if I wanted to get it to kind of show me something, it'd have to be clicking. So unfortunately, I'm not going to get any new science from this mission. That's a shame. So I'll have to design something better where I can hit the moon more precisely. So fair enough. All right. So now I need to kind of plot out what I'm doing next. We need to design and test the Aegis upper stage, open up a new technology so we can make those re-entry vehicles for that next set of contracts. Yeah, I guess it's, what time? Come on. Mars, no. Oh, right. Backspace to go to the craft, which is something I only learned recently. And there we go. So it is daytime down at the Cape. All right, so let's go to the Cape, because this satellite is basically lost. I mean, it's going to do a flyby of the moon. It's going to do some nice things, but it's not going to be close enough to get to garner those new contracts, unfortunately. I might return to it to get, science from space high and science from the moon's vicinity, which I also didn't know until recently. I kind of suspected, but I never tested it. But if you have those contracts, so let me show one off. I think that's just telling me, oh no, it got high enough to complete that sounding rocket contract. Hooray. Crew, nope, crew. hopefully we'll complete some of those starting soon. So this one, transmit or recover scientific data. It doesn't have to be new science. You just have to have an instrument with some science out in space, transmit it, you'll complete this contract. It doesn't have to be brand new science. It's basically any science or any sounding rocket with some science hardware will be able to do that. So yeah, I'm not going to be close enough to the moon, unfortunately, to get that one. Obviously not going to impact the moon. Science data, but see, this one is an example. Even though I believe I captured all the science data with that probe last time I kind of fluked out a flyby, that I will be able to complete that contract. So thankfully I'll be able to complete every contract except the Lunar flyby uncrewed, which thankfully I still have like a year of in-game time to complete. So I can probably make a refined spacecraft capable of doing that. Which is nice. So past the Kármán line. I might actually do kind of what I was suggesting, where I set up solid rockets that are underpowered and then add some more RCS to it. Maybe I'll do that with my first Agena. I don't see why not, because the Agena was used for a number of moon probes that we'll get to later. Ranger might be one of them. Yeah, there's a number. It can't send the Agena upper stage, no matter what you attach it to, can't send a ton of mass by the moon, but it can send it can send enough to do some pretty potent things. So let's see, break sound barrier. Do I not have the recovery? Oh yeah, successful reentry. There we go. So see, I'd kind of wish there was a contract like this with, say, half the velocity, so you get a little bit of practice. But in practice, I basically need to be able to make like a little unmanned pod with like an avionics unit, an RCS, and a heat shield that's able to return from orbit. And there's big bucks you get from it. It's a good mission. So that's one that I will be looking at soon once I design a payload capable of doing that. Unfortunately, I haven't made a nice historical looking payload that's able to do that. But yeah, I've got a style with procedural parts that I can use to complete that. So thanks for watching the video. Unfortunately, we didn't complete the close flyby of the moon, but as you can see why. Right, that's the solid engine is it's pretty difficult to get that level of precision with the planning tools we have available in Kerbal. Even with that MegJeb tool that will give you an exact, really close encounter, it doesn't allow you to tweak the delta V a little bit that I needed for those solids. So thanks for watching. Look forward to making the next video. Bye.